Hello everyone and welcome to this channel. In today's video, we will look at the nomenclature of ethers. Ethers are a class of organic compounds also known as alkoxy alkanes. They are just like an alkane in which one hydrogen has been substituted with an alkoxy group. An alkoxy group is an alkyl group bonded to oxygen. So you can have the methoxy group, like when methyl is bonded to oxygen, that will be methoxy. When ethyl is bonded to oxygen, we have the ethoxy group, and so on like that. So these ethers have this following structure: two alkyl groups bonded to oxygen. So there are two ways of naming these ethers, and also based on this we can classify ether to be symmetrical ethers and asymmetrical ethers. So when the two alkyl groups bonded to the oxygen are the same, we call them symmetrical ethers, and when they are not the same, they are asymmetrical ethers. Example of symmetrical ethers is when we have two methyl group bonded to the oxygen. So since the two of them are the same, we call it an symmetrical ether. And when we have compounds like this, in which the two alkyl groups bonded to the oxygen are not the same, we have asymmetrical ether. So another example of asymmetrical ether is what we have over here. Now, how do we name ethers? So we name ethers, number one, we can just name them using their common name or their IUPAC name. So we can use the common name, that's the first one and the easiest, and then their IUPAC name. So what we'll be dealing with here is the IUPAC nomenclature. The common name is very easy. So just name the two alkyl group at the two sides of the oxygen, then add ethers at the end. For instance, the alkyl group over here is ethyl. If you number it, that's 2 carbon. So that's ethyl. So we have ethyl over here. And then here we have just 1 carbon, that's methyl group. So to name this ether, the common name will just become, now don't forget, we'll always name them alphabetically. So E comes before M. So this becomes ethyl methyl ether. That's the common name for this ether. And here, instead of you to say methyl ether, so you can just say dimethyl ether. And that's how you always name the symmetrical alkenes. Symmetrical ethers. Since the two alkyl groups are the same, just add di to the name. The two of them, di, then the alkyl and ether. Like you can also have diethyl ether. We have two ethyl group at the two sides of the oxygen. We have diethyl ether. So we have ethyl over here. We have another ethyl over here. So that will be diethyl ether. So which is another example of symmetrical alkene. So here this is cyclohexyl. So from cyclohexane. So it should be cyclohexyl. And here is methyl. So C comes before M. So the name of this compound would be cyclohexyl methyl ether. So all these are just the common name. So just mention the two alkyl groups at the two sides of the oxygen, then you add ether to it. So that is called the common name. Now, all by the IUPAC name. So don't forget, I told you they are also called alkoxy alkane, just like an alkane in which one hydrogen has been substituted with the alkoxy group. And of course, the alkane will always be the carbon or the alkyl group with the longest carbon. For instance, to name this compound over here, CH2, CH3, CH2, oxygen, and CH3. So the first alkyl group here is having 3 carbon and here it's having 2 carbon. So the 3 carbon will be the parent alkane. And that will be the parent alkane. Then you treat the second one with the lowest number of carbon or lower number of carbon as the alkoxy group. So the alkoxy group here will be methoxy group. So this will be methoxy group, and this will be the propane. It's just like a propane group that has been substituted with a methoxy group. So this will just become methoxypropane. Let's look at the other example we talked about. We have this oxygen and methyl. So this is having 6 carbon, 1 2 3 4 5 6, and this is having just 1 carbon. So this becomes the parent alkane, and then the name will become cyclohexane, and then you treat this as the substituent, which is the alkoxy group. So this becomes methoxy cyclohexane, methoxycyclohexane. So we can also have another example. Let's say we have so if you have something like this, so the longest carbon here, if you check 1 2 3, and here we have 1 2 3 4 5. Okay, so this will become the parent alkane. And how do you name that? Number one, you treat this as an alkane, so it's having one substituent over here, and you treat this also as the substituent. So the substituent over here, which is the propoxy group, alkoxy group with 3 carbon will be propoxy group, so that will be propoxy. And then we have methyl group here, so that will be 1 methyl propoxy or 1 propoxy pentane. So the longest carbon here is 5, so that will be 1 methyl propoxy pentane. So that's the correct name for that. So we can equally have compounds like so to name this is having 5 carbon here, and this is having just 2. So this will be the ethoxy group, and this will be cyclopentane. So we have cyclopentane as the parent, and we have ethoxy cyclopentane. So don't forget, you don't put space there, so you write them together, ethoxy cyclopentane. So that will be the name for this compound. Now let's look at this example over here. So for instance, we have so how do you name this? Don't forget, this is the oxygen that is joining the 2 alkyl groups together. When you check the right side, you will see we're having just 2 carbon, and when you check this other side, you will see that we're having 1 2 3 4 5 carbon. So this becomes our parent alkyl. Now along the chain, we are still having another methyl group as the as a substituent. So how do you name this? When you name from the left, from the right, we are having the position 4 for our substituent, another position 3 for our substituent. So 3 plus 4, that makes 7. And when you number from the left, or from here, 1 2 3 4 5, the substituents are at position 2 and 3. So position 2 and 3 gives 5. So 2 plus 3 is 5. So this is lower than 7. So you follow the other numbering. So you follow the numbering from the right. Okay, so because it gives the lowest numbering to the substituents. So you don't follow the numbering from the left. So you follow this 1 2 3 4 5. So we have our position 3, we have 3 ethoxy. So ethoxy comes before methyl, so that will be 3 ethoxyl, 2 methyl pentane. So the parent will be pentane. Now let's look at this compound over here. You can see that the longest continuous carbon chain over here is 1 2 3. When you check this side, We are having oxygen here, so we have just one carbon here. 1, 2, 3. So this is longer than this, and when you check this as well, we have one carbon over here, and then 1, 2, 3. So this will be our longest continuous carbon chain. Now think of that as an alkane that is having two substituents at this first position and at the third position. So the name of this compound will just be dimethoxy, because we're having two methoxy group at the first and the third carbon. So that will be 1, 3 dimethoxy propane. So that will be the name for this compound. Also, we can have an alcohol functionality. We have an alcohol functionality. How do we name this? So when you check the oxygen, you can see, of course, this side is having one carbon, so that will be the substituent, because the other one is having 7 carbon atoms. So how do we name this? Now we check for the functional group. The main functional group is alcohol. So you number so as to give your alcohol, which is the main functional group, the lowest possible number. So when you number from A, the alcohol will be having 4 as the number, okay, and here it will be having 3. So you follow the one that gives you the lowest number, and that's the naming from the right. So we have 1, 2, 3, 4, 5, 6. So here we are having the substituent, the substituent at the 5th carbon, which is chlorine, and we're having another substituent at the 4th carbon. So we're having 5 chloro, and we are also having 4 methoxy. So alphabetically, C comes before M. So the name of this compound will become 5 chloro, 4 methoxy, then 1, 2, 3, 4, 5, 6. So that's X, hexane 3 O. So that will be the name of this compound. Let's look at one more example. How do you name this compound? Over here we are having 1, 2, and when you check the length of this carbon that joins with the next oxygen here, we are having 3 carbon. 1, 2, 3. So this side is longer than this side. So this side would be our parent alkane like that, and the substituent would be ethoxy, because we're having 2 carbon here, 1, 2. Now how do you name this? So it becomes 1, 2, 3. Okay, so and this ethoxy group, it has position 3 along the chain of this longest chain, which is the propane. So that would be 2 ethoxy, that will be 2 ethoxy propane. So and that's how you name ethers. So the nomenclature of ether could either be using their common name, so where we're going to be having the 2 alkyl groups named first, and then we add ether to it, or using the IUPAC nomenclature, whereby you check for the longest continuous, the longer carbon along, of the 2 alkyl groups that are joined to that oxygen. Then that becomes the parent alkane, and then the next alkane, the next alkane group, alkyl group, which is having the lower number of carbon, will be named together with the oxygen as an alkoxy group. So that's how you name them IUPAC, using the IUPAC nomenclature. So that's going to be the end for today's video. Make sure you like, share, and comment down below if you have any question, and make sure you finally subscribe to this channel for more educative content like this. Thanks for watching.